Assalamu alaikum. Welcome to another video. Today we will discuss chapter number 14, part 3. And the topic is conductors. So let's define conductors. Conductors are the materials that allow electric current to pass through them easily because they have free electrons that can move freely. Some of the key points regarding conductors are that they are used in wires, circuits, and electrical devices to transfer electricity efficiently. For example, copper, which is used in electrical wires because it is an excellent conductor. Silver, the best conductor, but it's expensive, so its use is less. Salt water. It conducts electricity well because of dissolved ions. Now we'll discuss insulators. Insulators are the materials that do not allow electric current to pass through them because they have very few or no free electrons. Its key points include that insulators are used for safety purposes to prevent accidental electric shocks. For example, plastic. Plastic is used to cover electrical wires for safety. Rubber is used in gloves and shoes for electricians to prevent electric shocks. Glass, it is used as an insulator in high voltage power lines. Now here is a quick trick to remember the basic difference between conductors and insulators. You can consider conductors as an open highway for electric current and insulators as a closed door for electric current. So basically, conductors are like smooth highways with free electrons, allowing electricity to move quickly and easily, whereas insulators are like blocked roads with no free electrons, stopping electricity from passing through. Now let's study the two ways in which resistors can be connected. Number one is series combination and number two is parallel combination. So let's define series combination. When resistors are connected end to end such that there is only one path for the electric current to flow, it is called a series combination. Key points are that current I remains the same through all resistors. Voltage V gets divided across each resistor. Let's move towards the derivation of series combination. Consider three resistors that are connected in series R1, R2 and R3 with the total voltage applied across the combination. Step 1 is we will apply Ohm's law to calculate the total voltage. Total voltage is the sum of voltages across each resistor. So as we know V is equals to IR according to Ohm's law, we will define V1 as the product of I and R1, V2 as the product of I and R2, V3 as the product of I and R3. Step 2 is that we'll add the voltages. So V is equals to the sum of three voltages that are V1, V2 and V3. Step 3 is we will substitute the values of V1, V2 and V3. So the relation will be V is equals to the product of IR1 plus IR2 plus IR3. Step 4 is factor out the current. We will take the current as common and the relation will be V is equals to I multiplied with R1 plus R2 plus R3. Now by using Ohm's law, V is equals to I multiplied with R for the whole circuit, the equivalent resistance will be equal to the sum of three resistors. So the final formula will be equivalent resistance in series is equal to the sum of three resistors or up till n resistors depending upon the resistors connected in the circuit. An example of series combination can be electric heaters, heating elements in series. In electric heaters or toasters, the heating elements are connected in series and the same current flows through each element by producing an increase in the total resistance, controlling the heat output. Parallel combination. When resistors are connected in such a way that the voltage V across each resistor is the same, but the current I gets divided among them, this arrangement is called a parallel combination. Its key points are: voltage is same across all resistors, current I gets divided between resistors. Now let's move towards its derivation. Consider three resistors connected in parallel, R1, R2 and R3 with a total current I flowing into the combination. Step 1 is we'll apply Ohm's law to each resistor. I1 is equals to V by R1, I2 is equals to V by R2, I3 is equals to V by R3. Step 2 is we'll add the currents. Since the current splits in parallel, so I will be equal to the sum of three currents, I1, I2 and I3. Step 3 is substitute the values. We'll substitute the values of I1, I2 and I3 in the value of final current. So I will be equal to V by R1 plus V by R2 plus V by R3. Step 4 is factor out the voltage. Means we can take V as common and the relation will be I is equals to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now by using Ohm's law, we will calculate the equivalent resistance. That will be 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3, and the final formula for equivalent resistance in parallel will be the sum of the reciprocal of three resistors. So one of the real life applications of parallel combination is car electrical system. In cars, the headlights, radio, AC and other systems are connected in parallel. Each component receives the same voltage from the battery and they can work independently. To ensure that turning of one device doesn't affect the others, that is why we use parallel combination. Thank you.